A lot of things are going wrong in the world, and the more we focus on that, the more we often lose the belief that our own actions even have an effect. The piles of scrap in these scrapyards in themselves can make you question the world we live in. Why were so many of these things thrown away in the first place? Contrary to that intuitive notion, my idea behind these types of videos has always been that giving a new purpose to something small can still have a big impact on your own feeling of effectiveness. Over the past few weeks, I've been on the road a lot, hunting for interesting equipment, as I also showed in my last video. While traveling the country, I saw countless deserted buildings that are not being taken care of. And whenever I show pictures like that on social media, people from all around the world contact me because they are dreaming of owning and restoring a place just like that. But the truth is that these buildings are often not even on the market. Many families just sit on these properties and they are not selling them. It might be because the family can't agree what to do with it, and then they argue for years. Maybe their price expectations are ridiculous, or they are simply a line of noblemen that don't sell out of principle. These things are infuriating, but you won't change them, and that is why it's sometimes better to just focus on things that you can actually have an effect on. In that sense, let's see what we can find here today and see what we might be able to bring back. This big metal enclosure contains a lot of interesting components, and I took the time to salvage a bunch of these parts, and we will use them to build something new in this episode. And here are some parts of an alarm system that I'm also taking with me. Salvaged from this huge pile of sheet metal, I have been able to collect some bigger pieces that we will use to repair and modify one of my trailers today. This machine here has already been gutted to some degree, but I like this enclosure here that also contains some valuable parts. I separated it from that machine and will take it to the workshop. I also got my hands on this broken chainsaw and some other power tools that will have to play a role in this video. So let's get going then. This Bosch brand electric chainsaw is from the year 2020 and it looks almost unused. Bosch is a German company, but the saw was made in Hungary. When you turn it on, however, all you hear is a rattling sound. The motor is obviously spinning up, but no rotation is conveyed to the chain. With this saw, bar and chain can be removed very easily. That same mechanism is also used to change the chain and adjust the tension on it. In the next step, the oil is drained, and in order to get inside, you simply have to unscrew a number of screws, very similar to a simple power drill, for example. Inside we can see the safety mechanism and how it interacts with the on-off switch of the saw. Little holes also connect the oil tank to the actual chain. And it seems that I already found the problem. The electric motor is coupled to the sprocket that engages with the chain via a number of gears. Between this black gear and the motor shaft, we also find a shock absorber or dampener mechanism of sorts. The motor is connected to the gear via a spring, and that spring has snapped in half. See, all we would need to repair this saw is one replacement spring, but I wasn't able to find that part. All I was able to find is this entire gear assembly, which costs you about 40 euros. For a saw that only costs about 90 euros, it is very questionable if anyone will spend that money. And probably only to see that same spring snap again a few months later. This is why I decided to do it differently. After removing the spring, I'm welding the two ends of the assembly together instead. But I'm not welding them together very ruggedly, but only with a few small beads around the axle. In case there should be a very strong shock, the weld might just break apart. Now, I don't recommend to do it like this, and I will have to test the saw for a while to let you know if this was a good idea or not. The spring is there for a reason. But I also believe that the original spring is too weak and that it will only break over and over again if you just replace it. So the best solution might actually be a stronger spring. I also installed a new chain, which you can get for just a few euros, and did a little test. Let's have a look at this lot of parts that we were able to salvage. What we have here is a bunch of chokes wound on rather big toroidal ferrite cores, a big mains transformer, sometimes referred to as a control transformer, since its job is to supply electronic control circuits in an installation, as well as this assembly of wire-wound power resistors. I think I will probably reuse the cores of these inductors sooner or later. The power resistors could be used to build a dummy load, like I have done several times a few years ago. A dummy load can be used to test the performance of, say, a power supply or an electric generator, and see how it performs under varying load conditions. This primitive dummy load consists of a number of power resistors that can be switched in parallel via a bunch of relays. A more complicated unit that I built a number of years ago as well is this one. It only has one big wire-wound resistor. That resistor can then be used to simulate an adjustable load by means of a PWM. It has a microcontroller and can be programmed. Maybe I could give this idea a third try with the power resistors we found sometime. But there's also something that we can actually build here and now using the big transformer. I have some 110/120 volt power tools lying around here, and these tools are not exactly in high demand over here, since Germany has a 230 volt line voltage in residential homes and almost nobody has a use for 110/120 volt equipment. The control transformer's primary has various taps. Using the two outermost connections being +20 and 415, you could power this primary here with up to 435 volts AC. Using the 0 and 230 volt taps, you could connect it to a normal German outlet. It has then two separate secondary windings, one for 110 and one for 24 volts. The transformer's maximum apparent power rating is 1248 VA, and almost all of that, around 1200 VA, is for the 110 volt secondary. That means that it's rated for roughly 11 amps. The transformer weighs around 16 kilograms, by the way. The difference of 10 Hz between the 50 Hz of the German grid and the 60 Hz of the American grid is without consequence for most applications, by the way. It is true that an induction motor, for example, would spin a little slower in a 50 Hz grid, but power tools usually have universal motors, and their rotational speed is not a function of the line frequency. Most transformers here, at least, are built to work with both frequencies, by the way. The big angle grinder will need more than those 11 amps for a short moment when it's started and also when in heavy use, but it will need less than that when just spinning freely. The transformer will be able to supply the grinder with enough power on average. It would eventually overheat if you would use the grinder under maximum load for a very long time though. I think it's unrealistic though that that will actually ever happen to me, since the grinder is only used to make a cut here and there. So let's build a step-down transformer then that we can use here in the shop for my 120 volt equipment. So what I have here is a socket and an adapter for American style power plugs and an old rack mount enclosure that we can repurpose here. Also some aluminum sheets from the scrap to close that enclosure. First, some old parts that are still connected to that housing are removed. Then the transformer is placed in the middle of this aluminum base plate, because here is where a bunch of holes need to be drilled to fasten it. The old neon bulb indicator can stay. We will also need a new hole for this Schuko socket where we can then connect this adapter. We also need a power switch and an ammeter, and I think that can be placed here. I would also add a fuse holder to the front panel and install that in one of the old holes we find in the front panel anyway. In order to make a new hole for the socket to be installed in, I employ an old method that I have used a number of times a few years ago. If you don't have a big enough drill, just draw a circle, then drill a large number of small holes around its circumference and eventually punch out what is left. You can then use a file to make it look like something resembling an actual circle. But it doesn't have to be perfect as long as the socket fits inside. And after actually fastening all the parts to the panel and bolting the transformer to the plate, the parts are also electrically connected to each other. Now, I want to use these aluminum sheets to close the enclosure from all sides, but I can't find the time for that right now. But to test this device, we don't actually need that. Let's have a look at this control panel then. See, the reason why I always bring these kinds of industrial style enclosures home is that I often need them for projects that I'm working on, and it's just a matter of time before I will have a new purpose for this one here as well. There are breadcrumbs inside, and this machine might have been used in some kind of baking facility. I use a vacuum cleaner to get rid of those loose crumbs, and then I try to wipe everything clean as good as I can. The same goes also for the outside, of course. Since I will not reuse this panel for its original purpose, let's also remove those wires then. And also the cut off serial connector wire that connects to this Omron brand programmable terminal. I have now connected a lab power supply set to 24 volts DC to the terminal, and we can see that the display is actually working, but the backlight is malfunctioning. In order to find out why, this protective cover was removed and the display was then separated from the enclosure. By opening this little door on the back side, we can actually see the CCFL or cold cathode fluorescent lamp that is used to light the display. You might know this technology from flatbed scanners or the backlight of older laptops and PC monitors. And down here we find the power board. It has an encapsulated DC to DC converter and also a high voltage inverter circuit to drive the CCFL. In order to find out if the inverter works, I have connected a DMM with a high voltage probe in parallel to the fluorescent tube. At first I get nothing here, but by simply wiggling on the tube's connector and making sure that it sits properly in its socket, we are actually already back in business. So that was really easy. And this sort of thing happens sometimes as well. The same thing could be said about these two devices here. Once part of an alarm system of some unknown building, they look almost new. The flashing light still works, and so do the annoying alarm sounds that you can activate by simply choosing different sets of screw clamps here. The next item that we're going to have a look at is this trailer here. It was built in 1989, but I'm still using it almost daily. I bought it a few years ago for roughly 350 bucks, and considering that it had just passed the general inspection, that seemed like a pretty good deal. And yes, you heard that right. Just like with a car, any trailer has to pass a general inspection every 2 years here in Germany. And since I both repair and modify my trailers on a regular basis, I have been there many times and I know that game. Modifications to trailers mean, of course, also that you have to update your paperwork with the authorities as well every time you change something. But let's just say that they are much more lenient with trailers than they are with trucks and cars. Now, I've shown you some work on a trailer a while ago, but this is a completely different model. It is much more ruggedly built, and I will show some modification work later in this video. But first, I needed to do some repairs to pass the much dreaded general inspection that was coming closer and closer. So let's have a look at the trailer and assess some of the damage that I had to deal with here. Relevant for the general inspection and also really annoying for me was the state of this back door here. The wood had been rotting away for a while, and the steel frame was heavily corroded and completely gone in some spots. So I decided to completely rebuild that door. The first step was to unscrew the bolts that attach the door to the hinges. After removing the old door itself, a closer look at the hinges was possible for the first time as well. Being made of galvanized steel, a lot of the material is still okay, but in those spots where standing water would have been an issue, almost all of it is gone. Every sane person would simply replace those hinges altogether. This hinge has been painted over, and you can see that the steel under it has almost completely folded at one point. There's no strength left in this part. But let's see how I dealt with that in just a minute. In the meantime, I had already ordered a replacement board that had been pre-cut to the correct dimensions. By placing the old board on top of the new one, it was possible to simply use the old holes to drill new ones in the exact spots where I will need them. In the next step, a new steel frame needed to be made. Now, ideally I would have bought stock with a U-shaped profile that would fit around the edges of the board. I couldn't get my hand on those U profiles in time though, so I had to make do with ordinary L-shaped angle pieces. I think it will be just fine though. And instead of measuring the steel profiles, I just used the board to cut them to the exact length I needed them to have. After putting some preliminary tags on the frame, I inserted it into the trailer's back end to make sure that it could move freely before welding the frame properly. Don't be irritated by the white box sitting on the trailer, by the way. At the time I had used the trailer as a storage unit and had built this box protecting things that I had stored here on the property. The box is no longer in use though. In the next step, I used the TIG welder to weld the parts of the frame together. I also used a wire wheel to prepare the surface for the paint job that I would eventually apply here. And because of my natural stubbornness and the shade tree nature of this YouTube channel, in case you haven't noticed, I decided to save the old hinges instead of replacing them. I removed the rust with a wire wheel and then used the TIG welder again, this time to build up some material and strengthen the hinges. It was also necessary to insert pieces of stock on the outside to make that happen. Not the most beautiful weld I ever produced, but it'll hold. By the way, even with a lot of practice, welding outside with wind and weather on dirty, rusty or galvanized materials while kneeling down on a cold floor is something else than welding new stainless steel at a welding bench inside a shop, just saying. After coating the hinges on the inside, I eventually installed the new door. The board still needed to be screwed to the board, like it was done with the old door before. Eventually, MS polymer was used to seal the gaps between the steel frame and the board on both sides of the door, and to protect it from humidity. A few hours later, the steel frame was then also painted with hammerite. Not as good as proper zinc plating, of course, that goes without saying. So after all that had happened, I just passed the general inspection and have used the trailer with the new door many times and without any issues. And actually, about a year has went by. However, one thing that I never really liked about the trailer are the rather low sidewalls. The trailer is ideal for heavy, compact loads like these bricks here, but for lighter, more spacious cargo, it is always a lot of work to secure everything. So I just decided to build higher sidewalls with materials that I had found at a scrapyard. This is actually new material. It's offcuts and leftover material used in stamping presses for car parts manufacturing, as far as I know. These sheets apparently came from spools, that is why there is a slight curve to them. The brown stuff is not rust, but grease that actually helped in stopping these parts from rusting. Structurally speaking, the trailer is a rather rugged, welded steel frame that was later galvanized. In order to extend the existing frame, I will have to remove some of the zinc and weld onto the bare steel, and in order to grind the zinc off I need to detach the wooden boards. They would also get awfully hot while welding the steel. After removing the wooden panels I also scrape a lot of old silicone out of the gaps. After this repair, we will build a rain cover for the trailer and let it dry for a few months. We can then assess the state of these panels and see if they also need to be replaced. At this point, there really wasn't any time for that because I had to pick up some cargo only 2 days later. Next, I started to grind off some of the zinc coating around the spots where I was planning to weld. Now, the zinc layer is extremely thick and really hard to get off, which is a good thing, of course. In terms of rust protection, what I'm doing here means to weaken the frame to some degree. But the weak spot of this trailer is not the frame, which you can clearly see after 30 years, it's the wooden boards in those parts where you would have standing water when the trailer is exposed to wind and weather. After some stock has been cut with an angle grinder, the existing frame is extended. Since these parts are scrapyard finds, they don't fit exactly, of course, but they'll have to do. In the next step, I reinstalled the boards that I had dried a little bit while I was welding, and now the metal sheets were cut to length. Most of these are actually zinc coated as well, by the way. They are better protected against rust than just steel, but they are also harder to weld. As I mentioned before, the original frame was first welded and then coated at a hot dip galvanizing plant. The sheets are first tacked in place before they are then welded to the frame more permanently. And so it goes on and on until the 3 walls are at twice their original height. The frames are only really completed though once they go all around the sheets, meaning that more angle pieces are attached on the top as well. These gaps here aren't there on purpose, by the way. This happened because of a measuring error, and I will have to close them sooner or later. As I mentioned, I was kind of in a hurry. And shortly after, I actually drove off to pick up a secret cargo that I will reveal in a future episode. More work will have to be done on this trailer in the future, but at least I still found the time to paint the frame and also build this little roof that I'm putting on it whenever it's sitting here in the yard. I repeat, this is not for driving around, but just so the trailer is protected from rain while it's here on the property. Now, I have used the trailer a few times on extended trips and I'm happy with it, but I am aware that these modifications are a little rough and that it looks a little too much like a contraption from Mad Max for some people. But be that as it may, I hope that you liked this episode, and if that is the case, then please give it a like, just to let me know that I should keep on going making these types of videos. And if you want to help the channel a little more actively, you can make a donation via PayPal, a link is down in the video description, or become a supporter on Patreon under patreon.com/tpai. See you soon.